Hello everyone. In this video we're going to learn how to divide a polynomial containing more than one term by a polynomial which only has one term, and as we know those kinds of polynomials are called monomials. Previously we have learned how to divide a monomial by a monomial when we learned the quotient rule. In this video we're going to see what happens when the dividend has more than one term. The procedure for dividing a polynomial by a monomial is very simple, and it does not require the use of long division. Now, if you recall the rule for combining like fractions, which we have seen before, when you want to combine two like fractions, whether you're adding or subtracting makes no difference. We basically keep the common denominator. That's basically what makes these fractions alike, the fact that they have the same denominator, and we combine the numerators. So if we take this rule and go backwards, meaning look at it from right to left, if you write this side first and then set it equal to that side, this is precisely the procedure that we're going to use for dividing a polynomial by a monomial. So basically you split the sum or difference up into two different fractions, which is true according to our very definition of combining like fractions. Now, of course, this doesn't just apply with the numerator having just two terms. You can have as many terms as you like. In that case, you'll split it up in a similar manner. The first term divided by the denominator plus the second term divided by the denominator, etc. But the denominators are all the same, so it's the common denominator. All right, and again, no long division will be needed for this process. So here we have a problem which we will take a look at, and we're going to first go ahead and write it as a fraction. So we have 4x to the 4 minus 12x cubed plus 8x squared minus 24 over 4x. I do not recommend trying to cross cancel and do some of this in your head. In my experience, the students who get themselves in trouble are the ones who try to skip too many steps. So you do a little bit more work, but it pays off by getting to the right destination. All right, so now we will split it up. Again, I definitely would not skip this step. So plus 8x squared over 4x minus 24 over 4x. All right, so we basically wrote each term divided by that common denominator. That's all we did. We just split up that combined fraction. So now we'll go ahead and cross cancel the numbers as much as we can. We notice that 4's here cancel out completely, leaving just 1's. In the next fraction, 4 goes into itself once, it goes into 12 3 times. In the next fraction, 4 again goes into 4 once, into 8 twice. In the last fraction, 4 goes into 4 once and into 24 6 times. So now we'll go ahead and write the simplified version of those fractions. So in the first fraction, we notice that the numerical value of the coefficient is just 1. So we don't really need to write the 1. So we're just going to write x and apply the quotient rule. Do keep in mind all those x's in the denominator have an invisible exponent attached to them, which is 1. So when you apply the quotient rule, make sure you keep that in mind. So we get x to the 4 minus 1 minus the number left here is 3. So minus 3 x to the 2 minus 1 plus the coefficient of the next term will be 2 over 1, which is just 2. x to the 2 minus 1, and then minus. Now be very careful with the next one, because that x is going to stay on the bottom there, in the denominator position. A common mistake is for students to write 6x instead of 6 over x. So next we get x cubed minus 3x squared plus 2x minus 6 over x. And there we have completed the division. And that would be our result. Okay, so again, very simple procedure. Just split up the combined fraction and then simplify each of the new fractions that come about after doing so. And then simplify and cross cancel as much as you can, and you'll be done. So here we have another problem. Definitely try it on your own before you come back to the video. Alright, so we end up with splitting this up. So 25u to the 6 over 10u cubed minus 15u to the 4 over 10u cubed minus 5u squared over 10u cubed. Alright, so at this point we'll just cross cancel the numbers as much as we can, the coefficients. So 5 we know goes into 10 twice. Alright, I'm trying to change the color here. This does not always cooperate. Let's see, it goes into 10 twice, and it goes into 25 5 times. And in the next fraction, 5 goes into 10 twice and into 15 3 times. And in the last fraction, it goes into 10 twice again, into 5 once. Alright, so next we're going to have 5 halves u. We're going to apply the quotient rule to the powers of u, so you get u to the 6 minus 3 minus 3 halves u to the power of 4 minus 3. Remember the quotient rule, x to the m over x to the n equals x to the m minus n. So, and then finally minus 1 half u to the 2 minus 3. So now we end up with 5 halves u cubed minus 3 halves u to the 1, which we don't need to write, because if you write nothing, it's understood that it is, the exponent is 1, minus 1 half u to the negative 1. Now, it is extremely important not to stop at this point, because this is not considered the simplest form of the answer, given that there's a negative exponent remaining in the problem. So the last thing we need to do is just go ahead and move that downstairs so that it becomes a positive exponent. So finally we get 5 half u cubed minus 3 half u minus 1 over 2u. And that's how you handle that one. Okay, so here we have another one. By all means, try it first before you take a look at what I do. Alright, so we're going to go ahead and split it up. So we get x squared over 5x squared minus 10x over 5x squared plus 5 over 5x squared. Each term gets divided by the common denominator like that. Remember, this is just the process of combining like fractions in reverse. So let's take care of coefficient cancellation first. So here in the first fraction, there's no cancellation for the coefficients. In the second one, 5 goes into 10 twice, into 5 once, and these two 5s cancel out completely, leaving a 1 and a 1. All right. Now, normally at this point, we go ahead and write the coefficient that remains and then apply the quotient rule. But notice in this case, we have the same numerator and denominator powers, so we can just cancel those completely and be done with them. So they leave a 1. So for the first term, all we're left with is 1/5 because the x squareds canceled out completely as well. All right, so minus, now the numerical coefficient left is 2, so minus -2 actually, so minus 2. And then we're going to apply the quotient rule. Remember that x in the numerator has an invisible coefficient of 1. So we get x to the power of 1 minus 2 plus, there's no power of x on the top. We don't really need to use the quotient rule here, so we just get 1 over x squared. So that's 1/5 minus 2x to the -1 plus 1 over x squared. Remember that we do not stop at this point because we have a negative exponent, so the last thing we'll do is go ahead and move that to the bottom. So we get minus 2 over x plus 1 over x squared. And there we have that answer. All right. So make sure you can handle that before we proceed. All right, so here's an example with two variables handled exactly the same way. So we start out by splitting up the terms. So we get -20 u cubed v to the 4. I do hope you've tried it on your own already before rejoining us. So minus 5u cubed v cubed, and then we're not worrying about the signs at this point. We're just going to write them. We'll take care of them in the next step. So minus 15u to the 4 times 4 v cubed over -5u cubed v cubed plus 5u squared v squared over -5u cubed v cubed. Okay, so now we're going to go ahead and cross cancel the numbers. Again, leave the signs alone for the time being. Let's just focus on the numbers, the coefficients. So 5 goes into 5 once, into 24 times. 5 goes into 5 once, into 15 3 times. And here the 5s cancel out completely because 5 goes into both of them once, and we get 1 on 1. All right, so now we're going to go ahead and first take care of the sign on each term. So negative divided by negative, that'll be positive, which we don't really need to write. So we're just going to write 4. Now, as far as the powers of u are concerned, u cubed and u cubed, they cancel out completely. So we don't need to really get the quotient rule involved because that's just too simple. We'll just cancel them out. For v, we have v to the 4 minus 3. Again, in the next term, we have negative divided by negative, which gives us positive. This time we do have to write it down because it's a term separating positive. So we get plus. Now, we have a 3 here that's left, and there's a 4 we need to multiply it by. So we get plus 12. This time the powers that don't need the quotient rule necessarily are the powers of v, because they're both v cubes. So we go ahead and just cancel those. They leave ones, which we don't really need to write. So we get u to the 4 minus 3. And then on the next term, we have a positive and a negative, and when you divide those, that's going to give you a minus overall, so, or a negative. So minus u to the power of 2 minus 3 times v to the power of 2 minus 3, right? So we end up with 4v to the power of 1, which we don't need to write, plus 12u to the power of 1, which we don't need to write, minus u to the negative 1, v to the negative 1. And as you know, we're almost done. We just need to go ahead and make those negative exponents into positive ones. So we get 4v plus 12u minus 1 over uv. And that would be it. We'll finish with that at this point. All right, so very simple, just a lot of different things that could go wrong as far as tiny errors. So make sure you're paying attention. Here we have a geometric application. We're given the area of this triangle by this expression. We're given the height by that expression, a simple expression u. And we're trying to find the base. Of course, given that the area and the height are both given in terms of u, the base is going to be in terms of u as well. And given that these are variable area and height, the base is going to be a variable expression as well. So we don't expect to get base equals 5 meters or anything like that. All right. So as is the case with all geometric applications, we'll start by writing the formula that's applicable here. And we notice that that's just a equals base times height divided by 2. You may have seen that as area equals 1/2 base times height. It's the same thing. It's just that this is usually easier to deal with in this form when we're trying to solve equations, because we can always throw a 1 under the a and then realize this is a proportion, and we can cross multiply. You should always look for opportunities to recognize proportions so that we can cross multiply and quickly solve. Now, instead of substituting the value, the expression for a and the expression for h and then solving for b, since this is a much simpler equation, it's a lot easier to actually solve this for b first and then substitute. So to do that, we're going to go ahead and cross multiply. So we get bh equals 2a, and now we'll go ahead and solve that for b. So we get b equals 2a over h. So now we're going to substitute this expression here for a. So we get 2 times 12u cubed plus 24u squared plus 48u divided by, for h, that's the height, we're just going to substitute u. So we're going to have to distribute that 2 up here, so into all those terms. So we get 24u cubed plus 48u squared plus 96u over u. Now I know that I warned you not to skip the splitting up step. Well, this is so simple, we'll make an exception. What do you think? So here we're just going to divide each term by u, right? So we end up with 24u squared plus 48u plus 96. And that's it. That's the base. Now, they're not giving us any units, so we don't need to worry about units, and we're basically done. In case they had given us units, like if they had said u feet and then the area is that square feet, then when we give the present the answer, we would have just put that expression in parentheses and we would have provided feet or whatever units they gave us. So make sure that you can handle this simple application before we proceed. All right, before we finish this video, I promised to show you kind of a shortcut for handling these powers and divisions. Now, the handy skill we're going to go over is cross-canceling same base powers, but only as long as they have positive exponents. We will never try this if one or both of the powers involved have a negative exponent. To understand how to cross-cancel powers which have the same base and positive exponents, consider this. Notice that this means 5 factors of x on the top and 2 factors on the bottom. Now notice that we can cancel 2 of those x factors, and that leaves us 3 factors of x on the top, so the result will be x cubed. So we could have cross-canceled in this way. We could have kind of crossed out the x to the 5 and said x squared goes into x to the 5 x cubed times, and it goes into itself 1 time. So the result would have been x cubed. This is what we mean by cross-canceling same base powers with positive exponents. Now, if the x squared were on the top and the x to the 5 on the bottom, notice if you cross-cancel, you would have canceled 2 of those with 2 of these, and this time you would have been left with a 1 on the top and x cubed on the bottom. So when we want to cross-cancel in this way, we say x squared goes into itself once, it goes into x to the 5 x cubed times, and when we write the answer, we make sure we write it as 1 over x cubed, not x cubed. So let's practice that a little bit. So notice that basically, let's go back to blue. We know that the power that's going to be left is going to be where the larger exponent is, right? So we're going to say x to the 5 goes into x to the 5 once, and it goes into x to the 17, x to the, basically subtract 17 minus 5, what do you get? You get 12, so x to the 12 times. And we're going to answer this as x to the 12. Now when we have x to the 5 over x to the 17, we know that the remaining power of x, positive power of x, is going to be downstairs. So we say x to the 5 goes into x to the 5 once, and it goes into x to the 17, x to the 12 times. To get that answer, it's very easy. We always subtract the smaller exponent from the larger exponent, and we know what's going to go there. Okay. So of course, when we write the final answer, we're going to write 1 over x to the 12. Be very careful with that. For this next one, you can see the larger power is on the bottom, so y to the 5 is the one that's going to go into both. Y to the 5 goes into itself once, and it goes into y to the 11, y to the 6 times. So when we write the answer, it's going to be 1 over y to the 6. Now, on the next one, the remaining power is going to be on the top. So we have y to the 6 and 1. Alright, so the final answer is y to the 6. Notice this is no different from you cross-canceling, for example, when you have 27 over 3. See? When you cross-cancel, you say 3 goes into 3 once, it goes into 27 9 times. Well, think about it. You could have written 27 as 3 cubed over 3, right? And now you could have said 3 goes into 3 once, and it goes into 3 cubed 3 squared times, which is the same as what? 9. So we're doing something very similar to what we've done in the past with just constants and cross-canceling of fractions. So I just wanted to show you this type of cross-canceling in action by revisiting actually one of the examples we've already done to show you the difference in the level of efficiency. This can be done very quickly with this technique, but you have to be careful. So let's go ahead and split up the fractions as we did before. That part is no different. So 25u to the 6 over 10u cubed minus 15u to the 4 over 10u cubed minus 5u squared over 10u cubed. So we're going to go ahead and start cross-canceling now, but this time we won't just cross-cancel the coefficients, we'll also go ahead and cross-cancel those powers because they have the same base and positive exponents. Remember, that's the only time we will try to cross-cancel powers. So with 25 and 10, we know 5 goes into 5 times, it goes into 10 twice. Now with u to the 6 and u cubed, we know that the smaller power u cubed goes into itself once, and it goes into the larger power u to the 6 u cubed times. And that 3 can be found by just doing 6 minus 3, as you know. Now for the next term over, 5 goes into 15 3 times, it goes into 10 twice. Now u cubed, which is the smaller power, goes into itself once, and it goes into the larger power on the top u times, right? For the next term, 5 goes into 5 once, it goes into 10 twice. U squared is the smaller power, it goes into itself once, and it goes into the larger power down below u times, okay? So now we can get to the final answer already. So we have 5/2 u cubed minus 3/2 u minus 1 over 2u. And that is as simple as this kind of a problem can be if you carefully cross-cancel powers which have the same base and positive exponents. Now, so that's the final answer. Let's quickly go back to example 2 and see what we did there. See, in example 2, we did the split, then we cross-canceled the numbers, then we applied the quotient rule, and then we got this expression which still had a negative exponent, and we had to move it down to get this final answer. But now quickly go back to the previous one that we just did. We bypassed a lot of the things we did before by doing this kind of cross-canceling. But remember, this should only be done if both of the powers for which you're doing cross-canceling have positive exponents, never with one of them having a negative exponent. The only exception would be if I were to say it's okay to cross-cancel with negative exponents. Let's say you have x to the negative 2 on top and x to the negative 2 on top, and they're the same, and you want to do that and say that's 1, that's fine. But other than that, where there is complete cancellation, do not try this with negative exponents. Alright, so that should do it for this video, and make sure you practice and stay safe until our next video.